Okay, good day students. We are now here back in our new lesson. So, in our given problem, we need to determine the indicated term in the given geometric sequence. Now, there are all different ways to determine if that specific sequence is a geometric sequence or an arithmetic sequence, which is actually our previous lesson. Now, at this point, if you're asked to find the indicated term on a given geometric sequence, it's very applicable that we need to use the geometric sequence formula. But at this point, before you will know if that is a geometric sequence or not, we need to identify if that is a geometric sequence or an arithmetic sequence. So I have here an example. If we have a sub 9, it indicates that what specific term, that is the ninth term, a sub 9, you have the sequence 2, 4, 8, and 16. Now, we all know in our arithmetic sequence, if there is a certain constant number that needs to be added to each term to find the next term, that is an arithmetic sequence. And that certain constant number, we call it as a common difference. Now, if we try this one, we need to find the common difference. We all know to find the common difference, we just simply subtract the numbers from the right going to the left. If that is 16 minus 8, you will arrive at 8. Okay? Then 8 minus 4, you will arrive at 4. Then 4 minus 2, you will arrive at 2. So it indicates that this certain sequence is not an arithmetic sequence, hence they don't have a common difference. 2, 4, and 8 are not common. Okay? So therefore, it means that this sequence is actually a geometric sequence. Now, how can we identify if that is a geometric sequence? That is a geometric sequence if that certain constant number will be multiplied to each term so that you will arrive to the next term. Okay. Now, we call that one a constant number as a common ratio. Okay. So, how do we find a common ratio? Again, common ratio. Common ratio stands for the abbreviation R. Now, the question here is, how do we find the common ratio? If in arithmetic sequence, they have a common difference, we simply subtract the numbers from right going to the left. Now, in geometric sequence, that certain common ratio will be multiplied to each term so that it will arrive to the next term. Okay. Now, to find the common ratio, we just simply divide the numbers from the right going to the left. Again, we just simply divide the numbers from the right going to the left. So which means that is 16 divided by 8. Okay? Then you have 8 divided by 4. Then you have also 4 divided by 2. So what is 16 divided by 8? You get 2. 8 divided by 4, you get 2. While 4 divided by 2, you get 2. And that is our common ratio. Okay? So again, in common difference, subtract numbers from right to left. In geometric sequence, we call that number as a common ratio. Hence, we just simply divide the numbers from the right going to the left. So those are the ways in how to identify if that specific sequence is a geometric sequence or an arithmetic sequence. Okay. At this point, since we need to find the indicated term, which is the ninth term of this geometric sequence, we will use the geometric sequence formula, which is a sub n is equal to a sub 1 multiplied by r, which is the common ratio, raised to the power of n minus 1. So this is the formula to find the specific term of a geometric sequence. So the same as usual, we need to find the a sub 1, the n, and the r, since this is already a geometric sequence. Okay? As usual, a sub 1 is the first term of our given sequence. 2, 4, 8, and 16. What is our first term? That is automatically 2. Okay, the first term. Your n here is the specific term that you are looking into, which is a sub 9, which is the ninth term. That's why n is 9. Your r, or the common ratio. So again, the common ratio is 2. Okay. Since we have already the value of your a sub 1, n, and the r, take note, the substitute the values a sub n is 9, so that's a sub 9 indicates the ninth term. That's what we're looking into. A sub 1 is 2, so put it inside the parentheses 2. And then, since it's also a multiplication, that dot indicates a multiplication, you can also put a parenthesis to indicate r. So r is also 2. Close parenthesis. Raised to the power of n minus 1, your n is 9. So it means that is 9 minus 1. At this point, you need to simplify first the exponent. Okay? This n minus 1 or 9 minus 1. So copy first to the a sub 1. Copy also the r, which is 2. Then 9 minus 1, that is 8. Okay? And then, by virtue of PEMDAS, we need to simplify first the exponent with parentheses. So, copy first, again, the first 2. And then, 2 raised to the power of 8, if you can still recall. 2 raised to the power of 8 is 2 times 2 times 2 times 2 times 2 times 2 times 2. Okay, those are 8 2's. Then you multiply it. You will arrive at 276. Am I right? Okay. So, if you can still recall, okay, 2 times 2, that is 4. Okay. Times 2, that is 8. Times 2, that is 16. Times 2, that is 32. Times 2, that is 64. Times 2, that is 128. Times 2, that is 256. Okay. Times 2. So 2 raised to the power of 8, that is actually 256. Then 2 times 256, that is 512. And that is our ninth term of our sequence. Okay, so that is 2, 3, 4, 5, 6, 7, 8. Okay, that's 2 over 8 is 256. Okay, so therefore, our ninth term is 512.